you. G'day everyone. For those of you who I haven't had the pleasure to meet yet, my name's Megan Hancock and I work with the sciencey part of science monitoring and knowledge in JUNA. I would like to thank my wonderful colleagues who have spent the last 3 years on and off working on different components of research in this basin. I'd also like to thank the IESC, who you've already heard about, who work for the office, who run out of the Office for Water Science in Canberra. But a very special mention goes to our Jedi in the science unit, who showed great patience with a young whippersnapper like me who loves to test boundaries. So for those of you who haven't worked in government before, you quickly learn that when you work in government, you don't always accept the first answer you're given. So I wasn't quite happy with this, so I went to the next principal. Apparently LSD is just as bad as acid, so I went to the next principal. Oh, I can't say that. Mike, we got any ecologists in the audience? I love you guys, I love you guys. So I obviously wasn't happy with that. So luckily for me, despite all the redundancies in the last decade, there was still one more principal that I could go to, who just happens to be my manager, and he's fantastic. So let's go to the western edge of the Simpson Desert here, where the Larapinta or the Finke River overlies the Pedirka Geological Basin. And in addition to acknowledging that we're on Kaurna country today, I'd also like to acknowledge and pay respect to the many different traditional custodians of country that we've been completing our research. And I pay my respects to their elders, past and present. So the reason we've been researching this basin is twofold. Firstly, we know that there are many existing groundwater users in an area where groundwater is the only reliable resource. So we've got town water supply wells, we have pastoral operations, and you've heard about really important cultural and environmental assets like Dalhousie Springs in the south. But two, we know that there's plenty of coal in this basin with really high potential for coal seam gas and large coal mining. And I'll come back around to that right at the end, but today I want to do something a little bit different, and I just want to share with you a small component of our literature review, which is how this basin was formed, because it really is extraordinary. It's so extraordinary that's kept a Gen Y captivated for 3 years now. Let's start with the photo that inspired the title of this talk. So imagine that you're standing on the western edge of the Simpson in what is now desert, and you're talking to a geologist about those mesas in the background, which are the strange flat-top rock formations you can see. And he says to you, isn't it just mind-boggling that they were deposited by glaciers? I don't know about you lot, but that is what was going through my head. And it turns out our mate the geologist wasn't pulling my leg. It was way back in the Permian, nearly 300 million years ago, when all of the continents were joined together in one supercontinent called Pangaea. Our region was covered with polar ice caps, and it would have looked something like this. So for millions of years, we had huge glaciers slowly moving across our basin, depositing rocks and sediments and mud as they went. Lozzie, where are you? Everyone, this is Lauren Hoothausen, who did an excellent presentation yesterday on Hookina Springs. So Lozzie came out on a field trip with me, and if you ever want to see hydrogeologists absolutely loving their trade, you should have seen us standing in the desert on a glacial outcrop collecting rocks. We were just like kids in a candy store. Until the next day when I broke the groundwater pump and we had to go home. So let's fast forward a few more million years and our climate is warming. The ice is melting and our glaciers are retreating. And we end up with something like this. The rocks and fossils that we find in our drill holes today tell us that our region for a long time was characterised by really low energy environments and swamps and peat bogs like this. And on a side note, while I was Googling around for images of peat bogs, I learnt about this event. The annual International Peat Bog Snorkeling Championships in Wales. What an interesting cultural practice. It happens every year in August if you've got a wetsuit and you'd like to come. So some of these organic rich sediments that were deposited in these peat bogs and swamps now have been lithified into the coal plays that these days are the subject of much exploration. let's fast forward a few more million years and we enter the Jurassic, and this is a very exciting time for future geeky hydrogeologists like myself. So the scene is, the climate is warm and it's humid, CO2 is more than 7 times what it is today, and there are no polar ice caps. And our region then looks something a little bit like this. So there were rivers of Amazonian proportions, and our landscape was pretty much, for a few million years, a shifting mosaic of rivers, lakes and swamps. And fluvial sediments were deposited en masse that formed the Great Artesian Basin, the largest aquifer in the southern hemisphere that we currently know of. And the distribution of these sediments across 4 states, four states, tells you a little bit about what this whole region might have looked like back in the Jurassic. Let's fast forward a few more million years and we enter the Cretaceous. Our region is now covered by the great inland sea that poor old Sturt was looking for in the 1800s. By the way, I've pinched this map from Twydale, but that's my colouring in, you can see. And the older I get, the worse I am at sticking between the lines. Let's go up the sequence into the Paleogene and we enter the realm of the Larapinta, or the Finke River. So these two fellas down the bottom here, Ed Goose and Ahmed, studied the paleo drainage patterns of rivers in the Northern Territory. And for those of you who don't work in the area, that simply means the old school path that the river followed. The grey lines you can see show the modern day path of the river, and the blue lines show the paleo drainage path of the river. So the Finke River has been following a very similar path for around 40 million years. And that is a bloody long time in anyone's book. This river has seen so much history. Fast forward 20 million years and it's seen huge freshwater lakes in central Oz, and the fossils tell us that they were filled with crocs and giant flamingos. Fast forward another 20 million years and we've seen megafauna grazing on its banks. Roos that were 8 foot tall, wombies the size of a 4-wheel drive, and marsupial lions that definitely look like they'd tear your face off. Even in the last 100,000 years, this region has seen so much climate change. So this is a picture of Kaditunda, or Lake Eyre, which is just down the track a bit to the southeast. And in the floods in 1979, everyone was super excited when it was filled to a depth of 6 metres. Compare that to 100,000 years ago when it was permanently full and 25 metres deep. It would have been such a good spot to roll out your swag if you could avoid the marsupial lions. Since that time, the region's seen increasing aridity, particularly in the last 50,000 years. And it's even been through the most recent glacial maximum, or the last ice age, when sea levels were 120 metres lower than what they are today, and you could pretty much walk to Tassie. So can I be really cheeky and conduct an audience poll? Because I'm going to take on a professor and I need some data. Can I get a show of hands who knew that 20,000 years ago sea levels were 120 metres lower than what they are today? For those playing at home, it's probably about a quarter. Great, thank you. I'm going to use that one at the pub later on tonight. So if we are to summarise our basin's history, we have the Glacial Formation down the bottom. Then we had peat bogs and swamps, which form the coal. And then we had supermassive rivers, which now form the main aquifer in the region. Then we had an inland sea, the sediments of which now form the confining layer for our aquifer. And overlying all of that history, we have the Finke River. And now you can see this, you can see the conundrum, and you can see why we've been out there researching for 3 years. The formation containing the coal is directly beneath the main water supply in the region. Which brings me to the key products and findings from some of our research. So this was a report produced by my colleagues who did some new drilling out in the middle of the basin and found that the formation containing the coal is hydraulically connected to the overlying Great Artesian Basin. So for those of you who aren't hydros, what that means is that we dewater or pull water out of the formation containing the coal to get to the energy resources, there's a really high probability that we're going to affect that overlying aquifer. The second is a report about modern day recharge processes from the Finke River into the Glacial Formation, which is the blue formation you can see there. And if technical reports don't blow your hair back, These are summarised on an award-winning poster out on the lawn. The third is a first cut Class 1 numerical groundwater flow model. For you guys who don't know much about groundwater modelling, they take really specialist skills. Who are the groundwater modellers here? We've got a famous one here. So these guys have to know so much about hydrogeology. They've got to have really strong mathematics. It takes them months to build it, and they often cost upwards of $100,000. So if you were in Dan Pearce's talk this morning, you'd know about Juna's Model Warehouse, which is partly about sharing this intellectual property and making it more accessible to third parties. And finally, my colleague Stuart Wright has written a really nice little script to get 3D models from ARC software into PDF software. So these are really cool in that you can turn layers on and off, you can spin the basin, you can overlay groundwater data, or maybe you can see what seismic data is available. But because they're in a PDF, they're much more accessible than traditional 3D software. So thank you all for listening, and for my fellow introverts who aren't going to ask any questions, come and have a cup of tea with me out on the lawn. Thanks.
Thanks very much, Megan. It's always refreshing to have somebody be able to explain in the great black art of hydrogeology in an accessible and entertaining fashion. So that was terrific. So thanks for that.
Pleasure.
Questions?
Damn it.
Can you pick up the paleo course of the Finke going through to Lake Eyre from your studies?
Yep. So if you go to that paper, Ed Goose and Ahmad, they study the course of all of the rivers in the Northern Territory over the last 60 million years, and I just pinched 3 shots out of their paper, but there's about 18 shots, different time splices throughout the whole period.
Which paper was that?
Let's go back. Where was it? Ed Goose and Ahmad. So these guys work for the Northern Territory Geological Survey. I think it's chapter 26 or something like that. Pleasure.
Yes.
Are the politicians going to take any notice of the hydrogeologists when it comes to the impact of coal mining on the water reserves?
It's a good question, isn't it? Well, the funding body for this research was the Independent Expert Scientific Committee on Coal Seam Gas and Large Coal Mining, and they operate from the Department of Environment in Canberra. So they're the ones funding this research, and all of the stuff goes back to them where hopefully they use it.
The whole process was designed so that this committee can provide independent expert scientific advice to government in relation to approvals that are associated with coal, seam gas and large coal developments. So in theory, that's exactly what the process is set up to do.
Hi.
Are there any faults or fault lines in that area or seismic activity?
Yep. So the glacial formation down the bottom is mainly clay, so it's really thick, it's really old. There's definitely been tectonic activity there, so there's definitely fractures. And then when you think about the overlying Great Artesian Basin, the reason why it's so good is because it's highly fractured sandstone and the transmissivity is really high. So yes. But Mark, are you here? He's a geologist and he'd probably be able to answer that a little bit more specifically than what I could.
I think we need to move on, but I'm sure the conversation is ensuing. This is important work in the sense that some of the other work that has been done in relation to the Great